Welcome back, guys. Last time I wanted to do some refactoring first. I still remember about it. I was interrupted again by the same angelic voice. This time she's sleeping, so we can do some refactoring. And today I came prepared for a very tough topic, syntax highlighting, especially if we were focused on AST and we were mostly doing transformation from the code to AST, then evaluating the AST, and then type checking the AST by actually evaluating it. But syntax highlighting is a little bit more low level, and we have something to talk about it there. So let's have a plan for today. First of all, we do some syntax highlighting. Also do finish the refactoring. Yes, should be fine. Yeah, I think this is it. And it sounds like it is easy to do because we already have lexer, we have parser, and we just simply syntax highlight. But it's not exactly, and I'll tell you the story. But first, slightly off the topic, quickly finish this refactoring. I started over. We want regular expressions to actually parse all of them, not only just 3-letter long one. So currently it cannot be applied and we do the type check, and currently we don't really need it, so we just do what we have to do, even if it's not type correct. So let's break the lexer first. Source, and I'll have full 1, 2, 3, bar, I don't know, 7, something like this. Okay, I expect token type and the file, go to numeric literal. Yeah, it thinks that this is the last symbol of the regular expression, even if it's not slash. It actually ignores it, doesn't check, and doesn't make any decisions based on that. So then it continues parsing and sees numeric literal, which is not expected. Here it should be operator or something else, and the parser decides that this is not an operator. Then the plus parser stops trying to find any more tokens, and then the only last subparser kicks in, which expects the end of file. So it expected end of file, and we should fix it. It is easy. So we see that the current character is slash, then we decide to start at that exact character, so that slash goes into the token span, and then we read the slash, and then we get the first letter, so I'll remove this. And if it is also at slash, then we read it, and then read the full comment. So that wasn't the bug, but it was not having next after the check. It just makes all the comments start with their second slash, which is not what we actually want. Okay, but it still can be parsed out. It's just cooler to parse the slash out here. Then return it, then we don't care. Now we know that it wasn't a slash, and it definitely is a regular expression because we've got a hint from parser that this is a value position, and it is definitely not an operator. So that means that something happens here, and we need to do the next while it's not slash again. And let's do it. while char is not slash, we just do next, and it is definitely not character here. We already checked it. If it is char, we go there. If not, we come here, and we know it's not, so we can eat first character of the regular expression simply. Then we do the while check again. So it's actually do next while, something like that. No, we did next here explicitly, then we check it again. If it isn't, we continue stepping forward and checking. All good, should work. Then we stand on the final slash, and regular expressions have their quantifiers, options like case insensitive, Unicode, global and stuff, and we will not support it because we don't care for now. Once we need it, we come back and we just fix it. And then the last character is slash, and we do end at that character, right? Because we have the, I don't remember if we have inclusive or exclusive end. Let me double check. Where is number? Next. So operator plus, start, next, and so next and is exclusive. That's good. That means that we need to read the last slash. Good. And then that's the actual end. That also means that no, it doesn't mean anything else. Should work out of the box. It works. Great. Okay. Does it really work? Oh, sorry. Yeah. And let's see if just single character works. If it's 0 character, it becomes yeah, it becomes just a comment. Does it care what's inside? No. Yeah, all good. Should be all fine. Yeah, it works. So now we have almost full support for for regular expressions. So git add, and then what we do is extend support for exps. I think this is a good start. Finally. Okay, looking at the wrong editor. So now I'm going to do, checking this thing. Yeah, a little bit of procrastination. So this topic I was a little bit afraid of because it requires things which are not as funny to watch usually. So this is why I actually implemented everything the first place like a year ago, and found out that okay, lexing, cool, parser, quite nice, especially we can finish with finish the example with a quite small parser. Just how many lines? It's 100. It's good. But then I started looking into syntax highlighting, and I tried to attack the problem with AST and finding what a position is. So given a position which I need to highlight, I wanted to highlight per character. And I was was trying to go through the tree, the AST, and it became a search tree. And it was boring, and it was not super fast, but it was very much context aware. So let's see at our source. For example, I hover, in our future videos we probably will cover this, I hover over this plus, and I know that this plus is an operator, and behind it there is a binary expression, and behind it there is another binary expression, and I using the AST I could have done this way, and I did it in the beginning. It was not super nice to see. It was almost 500 lines of code or something like that. And also it required me to work with not super convenient ways of searching using this line plus column, which is it's like a big int. So you need to remember that you have a almost arbitrary big column, but you also have a line which is always bigger, and you need to sort. Ooh, so it is messy. So then I wanted to finish it, because sometimes even having a messy approach is good. It's better than nothing, and I had very nicely highlighted messages in the error messages in the console. But I really didn't want to have this code for myself, and still I had the idea that maybe if I succeed and implement type checking, lexing parsing, and it is all fun, that maybe I will make a series of videos. So I had to find a better approach. And I kind of looked a little bit, being bored, looked a little bit at Babel, how it does parsing, just wandering around, and found that they not only produce AST, as we have here, so we just produce AST and we forget almost everything about the initial file. We know positions, but our positions all line plus column based, and it's nice. But then if it is all you have, and you have only AST and line and column, it is hard. This is what I've just described to you. It's really hard. You need to kind of recreate the file partially on demand when you need to highlight a line or a substring of a line or something like that. And it's really uncool. So I thought that maybe there is something else. And Babel also exports, when they parse, they export not only AST, they also export raw tokens, which is interesting. So when we do the parsing here, we always fetch when we do parsing, we always fetch a token, right? Sometimes we tell it that the mode changes, so we give the feedback to the lexer, and the lexer always, given that, the lexer always produces the right token stream. So I'd like to illustrate this, especially here with this nice example with slashes, like 1 plus 1 divided by foo. Again, that's simpler. So first we start parsing, and we know that this is a number, then it's a space, we don't have anything, so we skip this thing. Then this is an operator, and we know it because the parser knows that, if you remember, after a sub-expression, a number, or a regular expression later, like a list or function call or something, we only can have an operator or an end of line, right? So end of, like, semicolon, fake semicolon, this imaginary semicolon. But there cannot be a regular expression. This is how we distinguish them. And that means that the lexer, which parses that slash, it knows already that it's an operator, and feeds it back to the parser, and parser gets the right token. So that means that when we read the token here, we always get the properly parsed token lexed plus slightly parsed token, always. And we never change it. We don't need to change our mind about this token, and we, in our simplified JavaScript, we can just rely on this information. And here it will be a regular expression all the way long, because it is just a token, and it's a regular expression, and it's 1, 2, 3, 4, 5 characters long. And this is enough. I found out that this is enough, and we can write a quite simple function when we match. No, it's not exactly enough, but it's almost enough. When we need to highlight line, we just need to find so imagine we have multiple lines and we want to highlight this one. We just want to find the first token, because oh yeah, also interesting, in AST you have deeply nested nodes. Every node can be a child of some other node, and they overlap. So I had already functions implemented in that version, and that means that this thing, if we move it, this whole thing is a function, and then this is a function keyword, this is a function name, this is an argument list, this is a function body, and if I hover here, I need to find that this line plus column actually falls in the span, the line plus column span of the function body, but not like one, and not the function itself. So yeah, it is creepy. I found then later that playing with lines and columns is also not necessary. So instead of doing this nesting, first I canceled the nesting, and second I found out that I don't really want to know if something is at line 3 and then column 7. This is actually not what I really need to know until I talk to the user. And also, I don't really, when I syntax highlight, especially when I syntax highlight, I don't really want to know the AST or whatever. The only thing I want to know is that in the original file, I have just one single line of things. They are not nested. I don't need to calculate their relations to each other. If something goes after or before, or if I hover, what is the closest wrapping span, blah. So you see, when even done that, when I describe it, it is already a little bit messy, and I really need to write, to draw something to explain all the details. But if we switch to just tokens and we forget about lines and columns, and we only know the initial file, the source file, then we can simplify things as found in TypeScript parser. So it actually was \n. In TypeScript parser, I looked at the lexer. It doesn't really remember the line and column. It doesn't calculate it. It just remembers the position in the kind of character stream, treating all characters equal. So there is no special \n which we need to store in our position. And position, in our case, every position is every location is a start and end, and each start and end has line and column, la 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 la. And then they don't do this. They just store the position in the initial file, which gives us later, here we will see it, gives us a very gives us a guarantee that all tokens are sorted. So we can easily compare the position of a token start and know that, first of all, it goes directly after some other start or directly before, so they are ordered. and also they don't overlap, they don't nest. We don't need to think two-dimensionally, we only need to think in one dimension. And the only hard, kind of not anymore hard part, is that we need to know about lines when we talk to the user. So for example, we have an error message that at line 5 something has happened, and we actually don't know that it happened at line 5. We know that it happened at position 17, but we just look back and see how many \n's we had, and we know that this is a line 5. I don't know if we will really simplify it like this, but then even if we don't, still thinking linearly here gives us a solution. I will show you quickly the solution which I probably look at, which does syntax highlighting, and it is here, and it is this function which can be simplified. Done. So don't look at it. It is really that primitive. Yeah, it's actually, that's it. That's the introduction, I guess. And as usual, if you do lots of lead code and prepare for algorithmical interviews, you know that the right solution, if you know the right solution, the most optimal solution, it is almost always 10 times easier to code, and it will be simpler to understand than the first approach, which comes to mind if you use all possible data structures. So that's the good example. And I had something else funny to say, but we'll come to it later probably. Good. So where to start? We need to have probably a plan. So first, we need to somehow have both line numbers, because we want to have errors. Maybe we now do the type check because we need to have errors. Operator cannot be applied to types number and regular expression at source. All good. Let's maybe also add some comment 1, and then foo, yeah, all good. Save. Cannot be applied. That's true. Okay. To do so, first thing, what we should do, we should, now let's not plan it. No, that's too boring. We should store the position. Yeah, so this is why I had this very long introduction, because you know, a guy opens an editor and starts adding some positions. That would be not cool. And now you know that it's great. I cannot prove it because it will take like 3 sessions, 3 streams to really implement the AST-based approach. You will definitely die from boredom, and then I'll say, you know what, we could do this in 20 minutes now. Anyway, so we have here a cursor, and I think this is the position which we need to have. I'll probably just rename it to pause. And then when we create location, oh yeah, this is time. This is time. You see, we have this line column thing everywhere, right? Yeah, line column, blah, blah, blah. Yeah, this is time to finally refactor this into position, right? Line, column, yeah. Function, position, or maybe just pause because we call it no, position. Still, okay, return line, column, yeah, still good. Let's see how many times we have it. Okay, nice. Okay, good, should be fine. Yeah, nice, nice. Yeah, I replace it with position, and it just works, and it just works. Wonderful. So first of all, we have the cursor still quite local here. We don't leak it. Now we don't leak the number. Okay, here is also position. Anywhere else? Oh, right, okay. File, line, column. Good. Right. Nice. Should be fine. We can refactor it later, and that thing we already have in type checker, right? We should work with this. Okay, so it has line and column, and this is the position, and we had file. Where is the file? Also used quite a lot because we wanted to have it in the top lock. For now, should be good enough. Yeah, otherwise everything will be broken. Nice. So line is also only used there, and here, and here. Good. And column is used here, here, and also there when we report a syntax error. Good. Good for me, I guess. So let's add just the cursor then. Bam. And it's there. It's there. Wonderful. So, but that's not it, right? We also need to have our tokens somehow saved, and that's actually tokens. That's not tokens. That Lexer next. Those are not tokens. They're tokens. Actually, they are tokens, but yeah, let's not rename too much. And we have here then const raw tokens, something like that. We have raw tokens. Whenever we do read the token, and token is defined. Yeah, I remember that we agreed that the tokens are always defined. If we read an undefined token, then it should be an exception. Really? How do we do this? How it happens? It happens somewhere here. And we do next to. Okay, we have. Okay. Token. It can be null, right? If we read undefined somehow, yeah, it can be, but still, we check it here. Well, we should have checked it maybe in the lecture, but anyway. Yeah, and here comes the question about comment token. Here we do ignore it, right? We say, okay, we swallow the comment token and we want next one. Next one also can be a comment token. We will eat it and hopefully will not overflow the stack. Probably we better do this while token type is we do next, and then anyway, this is still fine. And we need comment token to be in our token stream, so we don't do this. Where is token? We don't remember our token. Remember our raw token after we filtered out comments, because we actually would like to know that this is not just gibberish, it's a comment and it's a valid thing, and we give it a little bit shady color, and it's fine. So we actually move it here, and we will have all the tokens, and they will all look gorgeous. So nice. Yeah, now we need to return it. In the end, do we do it? Yes, the program is actually AST, and now the program is called AST. Yeah, and the raw tokens will be called just tokens. Nice. Yeah, we might do it differently. We might just tell, nah, all good. Or we always can do something differently. For now, it's good. AST and tokens. It should just work. Wonderful. Let's see how tokens look again. They look this way. We have a type and we have a location. We have a type, something, and location. Type, something, and location. Good, great. What do we need then? We have the stream. We know that it's always sorted. We know that the end is exclusive, which is important. But we don't have the actual content of the file, right? So there is this file, we read the input, and this is the content. And then we have content, and its representation as a stream of tokens. So first goes the comment token, then goes the numeric literal, all true, then div token, all true, then regular expression token, and then end of file. That's amazing. Okay, what I try to do first, maybe just make a module, sure. Highlighter.js. I'll just save it. Bam. Okay, and it will export highlight function highlight somehow. Right, highlighter, JS type check, highlight from highlighter. Oh no, highlighter.js has been taken, but okay, it's local. Oh, it works, highlight is there. Let's just do something like console log, highlight, and then we give it content, and AST. And the content is the raw characters, and AST, and tokens. Sorry, and token. Yeah, you see, I still live in that pre-tokenization way. So I think that we need AST to highlight. No, we don't. Tokens are there, and let's just print things, the content highlighted, just the full source. And actually, in our case, it might be even enough. We just once print it, and then we use a highlighted version for all the error messages if we need, but maybe not. Let's see. That might be the most simple solution. So we agree that we get content and tokens, and what do we do? Let's just return content. All good? Yes, wonderful. Okay. So how to move on? We can go first then. So it is there. This is also, I don't know, somehow we can do return tokens, join, and then something like that. And we have all good. That's all here. We can probably iterate over tokens and have let result as a string, and we can iterate for const token in or of tokens, and we just do res plus equal token type, something like this. Return res. Yeah, good. Comment token, numeric literal, div, yeah, they all look good. So what I'd like to steal from this project is colors, because this is exactly what I don't want to look up now. Again, as the NC colors, right? NC, I think. And oh, I had strings there. That's so sweet. Later, keyword. I also had keywords already implemented. That's nice. Operator, regular expression IDs. Later, number good, comment good. Keyword we didn't have. Should be fine. But how come that it's operator regex number token? I don't know. Anyway, that's first thing, and then what I'd like to also copy paste is this thing. Yeah, sorry. This is just to, okay, yeah, to wrap with the color the token and print it colored. So what we have type, and types plus space should work. No, prefix color is not. Yeah, should work. So comment token, good. Comment token, for now it's that stupid. Numeric literal number. Div token, it's an operator. Div token, regex token, as this one, orange one, and the file token doesn't have an operator, is just div token or mul token, or you see, we'll have groups of calls then to just have this nice highlighting language that every operator is this, but this one is that. Mul, and what else we have? Plus token. All good. All good. All good. Let's just highlight them. So const color equals colors by token type, and if we have color, then we add it with like this. Else we just do res plus equal t-type, and here we do res plus equal this thing. Okay, color t-type should be good. Yay, first colors, and they belong to the code. So if I go there in the source and I add plus and some other number, we have more. We have plus token, numeric literal, and then the file is not really rendered. Something comes. That's good. So other thing, we probably don't want to really highlight the type of it. We want to render the text, and let's see how we will do it. So let's see what we have in the token location. In the token location, we have cursor. Oh, you see, this is where the cursor comes to handy. If we didn't have cursor, we would have line 2 and column 12, and the content is just a string from 0 to how many, like 20 characters, and it would mean that we would need to map lines and columns to the original source, which is not good at all, I would say. So now we have this cursor. By the way, in TypeScript they don't have lines and columns. in the token stream or anywhere else, they probably map it later. So they have just the cursor or the pause position in the initial source code, and that's enough. That's very true, because you always can save the spans of lines, like from the beginning of line to the end, in a separate small array or I don't know, map and some other structure, which is one single optimized condensed I don't know, binary something in one place, and it's easy to always map it back to human facing. So it's like a little bit MVC. This is the model and this is the view already. This is for the user. We don't really care. Actually, if no error is happening, we don't need to even have this structure. So as you probably know from the V8 blog, they didn't have mappings from CSS. They don't. I think they still don't. In the main CSS engine, they don't really map rules back to their sources. So they had to, in the dev console, reparse the whole sources to have those maps. And now when they also support CSS and JS, they had to go around it. So kind of the same thing. If you understand everything what we have here, which is quite fancy still, it's not super easy to immediately comprehend, I guess, if you never had experience with parsers, but still it's the same. And it's kind of, everything is the same everywhere at this level. So it's nice to have practice like this anyway. Yeah, we don't implement anything super meaningful. It's just a sub portion of JavaScript. Still, it then resonates when you read something somewhere. It always happens, and I love it. I love this feeling. So now we have log, and we have log start and end. Let's try to get it from the content. So we have content, and we have substring, which I don't remember how it works. Will it help me? Nope. Maybe if I do it like this, it will tell me. Yes, thank you. Start number and end number. Wonderful. Start is zero base index number beginning, and end is zero base index number indicating the end of substring, so it's not length. Great. Thank you TypeScript. Thank you VS Code. Thank you Microsoft. You know, line and start cursor. Okay, log. Log. Is it exclude? We will find out. Log start cursor. Log start cursor and log end cursor. Probably will work. Bam. Oh, not bad. Comment. Don't know what. Probably it's comment and it's new line. Aha. Then it's one. Okay, let's check it. Source. Let's do it like this. Will one have slash? No. That means that within comments we have new lines. Do we really want to have it? Actually, no, but we'll fix it later when it becomes a pain, real pain. Good. Now we have content of the, like, let it call just text of the token. Okay, token text, or token content text. Yeah, that's good. And then you feel it, right? If we don't know how to highlight, we just output it, and then we just output it with the color. Let's see if it will work. Okay, nice. Wow, look, our first really highlighted text. Not perfect, but it's there. Comment is highlighted as a comment, and it has a new line. Aha, so we probably want to have a new line, and that's like a requirement. Is it a requirement or is it not? I'm not sure. Okay, anyway, So probably we can have, yeah, you see that we don't have white spaces. Probably white spaces might be their own tokens. Let's see. Might be good for if we want to do prettier later and we want to know which white spaces were there and don't ignore them. Might be nice, might be still nice. Okay, so comment 1, then we have 1, let's see, we have 1, and we have a slash, which is red, which means it is an operator, as plus is there also. Then we have foo in our highlighting scheme. It is all yellow, as it was in the in 80s. Here it's a little bit more convenient, then plus, then 0. Works. The highlighting works. So actually, I would say that that's the basic highlighting implemented. So why not to have a nice commit? Very basic and wrong highlighting. Highlighting implemented. Wonderful. Not here. Great. So far so good. What we can do, we must fix the spacing problem. Very nice. So there are two ways of fixing it. First, we just add a space and it just looks cool. So we always have a space there and we don't care. We don't care of the original formatting, and it's not nice, surely. So there are kind of two ways. First, we go over. Currently, we were going over the tokens, and it kind of nice. And we know that we only ignore spaces like white spaces, and we can add the spaces if they were there. We can guess because not all of the starts go exactly behind the ends. So sometimes there is something between the tokens and we can fill it with spaces, and we can finish it in like 5 minutes, I guess. But we really don't need it that much, because the next step would be that we implement just one line highlighter, I think. Maybe not in this screencast, but maybe in another one, because it's coming to an hour already, I guess. So anyway, the other way would be that we go over the content character by character and try to find if this character falls into next token in our, so this is what I probably did here. Yeah, exactly, there is a next token. If token begin position, yeah, I called it position there, then we do some kind of overlap matching, and then we just go, yeah. So it was done like this. I go over the code and see, okay, it's just first position. Is there a token for first position? Yes, great. Then I just take the token, print it, fine, I'm in the end of the token. It would be here. Is there any other token? Great, then I just take the token exactly as we did here. So I think this should go. So we can navigate exactly as we have it here in this very simple implementation. But then I look, okay, is there, and I go over, and I jump over the source code and jump forward to the end of the token I consume. And if I see that there is nothing else, so okay, is there, does the next token start at my position? No. Okay, then I just print whatever is there. Not a space, it might be anything which we didn't parse, we ignored, or there is some special character we must go over and it is there. Maybe there is a new line which I forgot to parse, or to map, so it is guaranteed that whatever will be printed will be exactly what we have in the source code plus some colors. So we don't really rely on tokens to rebuild the source code, because it is a loose transformation. At least in my initial attempt, I was losing information. New lines were cut off, comments, so actually concatenating the content like we do here of all the tokens wouldn't sum up to the original source code. But it is still kind of cumbersome to do all these mappings, and it's maybe not that perfect. Might be better for our demonstration purposes is to have to teach the lecturer to actually give the white space back. Let's see what white space returns, and it returns true in our case, right? And this is why we just an end of line also returns true, right? That or end of line, yeah, they all just return nothing. We ignore them. Let's maybe, to simplify things and to have this example complete, let's not ignore them. And what comes to my mind is that if we really want to do source to source transformations, for example, we want to teach our parser and lexer to rename this function next to something else, we want actually to find this relation between them, which is quite simple, and we want to map the file one-to-one with all the white spaces, with all the fancy characters we had in the initial file, but still in a structured way. That might mean that, yeah, to just evaluate the code, we don't need spaces, and that my solution here might be just copy paste and we just see everything. But it might be cooler to just have the exact match between the token stream, and then in the end, if we want to have it all in AST, for example, all the comments, white spaces might still be in AST if we want it. We just ignore them when we compile it to bytecode. When we evaluate, we just have an OP which does nothing. We would be able to have a nice opportunity to implement like pre-tier, but it's not in our to-do. Maybe something like true exception, something, maybe something like code rewrite as in pre-tier, maybe. But yeah, if we do everything right now, everything correctly, and we look forward, that might make it easier. So things we usually ignore is white space, end of line, and comments. With comments, we already knew that we need them, magic comments. Now with white spaces, we should probably do the same. So there is no true. Stocking is true, like throw one. Bam, good, we throw. But do we want? If token, let me see, if token, and we return token. If maybe end of line we do only once in the end. And here is actually unexpected character. Okay, end of line. But does end of line, I think end of line always matches. If character is undefined, yeah, it always matches. There is no way. It always matches in the very, very, very end of line. Yeah, it will produce all the, will continue producing end of lines forever. Okay, okay. Still nice, but if it's not end of file, then okay. So we kinda our end of file is our iteration terminator. We send it always. However, many times we get called. Still fine. Should work. So there is no more this thing. If there is a token parsed, then there is something to return. We know regex returns, number returns, operator returns, number returns. Nice. Um, that's super sweet. Maybe then we then just go into white space, and then we need to accumulate. So white space becomes something like a comment. It's a multi-line thing. So we just go and see how I did it there. So we just have exactly everything. Read comment and position. I see it. So the comment doesn't have actually the value. Nice. Okay, regular expression. Read comment, regex has it. Also no. That's uncool. So okay, let's then go one step to another. At least we return not true here, right? Yeah. If it is white space, then we just return something which looks like type white space type numerical control white space, and we need to have this definitely, yeah, to map it back. Maybe yeah, we do the map back. Yeah, for now we do map back. We don't really need the values. We get it from the original source. Might be a good idea, by the way. Might be not that bad. Start and of course we want to have const start equals position, right? And then end goes here. So it is not a white space, and end is exclusive. Should be fine. I save and I see what? Expected token type end of file got white space. Good. That means we go to here. We have if token is comment or it's white space, or in our case it would be what else? New line. Can we do it also as a white space? Yeah. For some reason I want it to be a new line because I guess it saves more. What? Yeah. It saves more semantic, maybe. Okay, so white space does this, and end of line also should do something like const start equals position, and we will return it the same way. If character, oh, it's so amazingly nice to write. Side note, to implement Lexer parser in a garbage collected language. And recently I've seen a nice thread when people said that, you know, some compilers written in C++ where you need to manually manage memory, they don't delete memory. They never free the memory, so they don't do memory management at all. And when you come to modern days and you have a kind of old school compiler and I don't know, everything, Lexer, everything, written this way, type checker, you cannot have it working next to your application and have this incremental builds or incremental type checks which work blazingly fast, because it just leaks. and it leaks all the way. It just doesn't expect to be stopped somewhere in between, but still I think having it leaking and restarting from time to time is better than having no tooling at all. But that's it. Here we have a garbage collector. We don't need to think of, okay, I return null. What do I do with the start? Should I also do delete starty here? No, I don't need to. It's all fine. Okay, and then that's amazing. Well, character. Then we count new line. So if it is, oh, I don't like it actually. I need to twist it. New line, and actually end, and end goes here, I guess. Yeah, tests badly needed here, but at least we have it. We have it. Really? Wait. Really? We don't add spaces here. Look, and we have the source exactly as it is. Ooh, even with the new line from here. Wow, it just works. Mamma mia. Oh, what's wrong? What? Yes, sure. I saved it one day. Okay, and then just 0. No. Unexpected token type, end of file token. Got numeric. Oh, for some reason we have here broken parser. That's fine. Yeah, because we don't have magic new lines. Yeah, okay. Yeah, that's true. We don't have broken parser. We just don't have new lines interpreted as semicolons, as expression terminators. Nice. Still it works and it's beautiful. I love it. I love it. As a front-end engineer, I like to see things in color. Wonderful. New line is there. This is here. What I didn't like is that actually if it's not, we just return null, close it, and then next new line. We know it is, we consume it, we add some semantic meaning on it, and then, well, character is new line, so if we have a series of new lines, we just consume them in one go, which is sweet, like this, right? Yeah, and it just works. Wow. But if we don't, we just have more of them in a stream. Yeah, it's just an optimization. So it doesn't change much. Oh, do we really want to have this optimization that we pack all the new lines in one? No, we don't, because it here. So currently we don't care, but later we might care because we can move this new line thing out of Lexer at all and teach parser to actually track the line, and yeah, we might think of it, but yeah, let's do it. It doesn't actually matter much. It simplifies the code, and people don't really have those big line number series in their codes. If they have, that's completely fine. It's just 15 tokens to parse. I think that's fine. That's fine. Usually the hot path should be that we just have one, maybe two in a row. It's fine. It's fine. It's fine. It's overthinking. Let's have. Oh, I cannot stop doing that. That's incredible. Yeah. Oh yeah. Oh yeah. Fingers. All good. So we have the syntax highlighter. It works, and it is exact. Yeah, and we did mess up with endings. It doesn't really lax or parse something which doesn't really belong to it differently. Yeah, infinity unimplemented slash good. Why? I don't know. Because it is plus, it is already a text, something like, oh, in JavaScript. Unimplemented slash? Unimplemented. Yeah, I know where it comes from. It's the value of the foo. Great. Yeah. And if I add more spaces? Wow! Wow! Just wow! 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 Yeah, I love it. Cannot stop playing with that. So I don't know. I'm still like a kid when it comes to this little magical things. Nice. Okay, I should stop. Just stop saying nice. Nice. Okay, that's it. I think we've implemented the highlighter, and it's not. And you know what's funny? It is way simpler than this, and it's easy to understand. So I think the third iteration, we decided to have exact token stream, which doesn't left any of the characters behind. It's good. Okay, exact token stream plus highlighting. Yeah, great. Okay, let's go to do. Add some syntax highlighting. So it wasn't like syntax highlight error messages, which is a little bit more advanced, and I think I'll do it in another episode. Let's say that it is it, and add it for later, that syntax highlight the error messages. Yeah, this is what we probably want to do. Is it hard? Is it really that? Can we do it right now? Let's just brainstorm a little bit. So we can have a completely highlighted version. We can just highlight the whole file. Yeah, but that's not what we probably want to do, because we want to be serious at least at some point and not do the unnecessary stuff. But anyway, if we badly needed to ship it now, and we know that usually errors happen in one file multiple times. Usually if you make some syntax, no, if you syntax error, it's different. If you make a type error somewhere, you will have the whole function read, and it is fine to have the whole file, which is usually no more than a few thousand lines of code, so it's like a few kilobytes, and like I would say 10,000 tokens. For modern computers, even if they are thin clients, it's nothing. So we could just highlight the whole content of the file, and actually we can store the content within tokens, probably, if we need. Do we need? No, we don't. We decided we don't want to optimize it out away. Then we just highlight it, and when we have a line, when we want to say that at some line, we just go there, split it by new line, and output our line, and it's super straightforward. Maybe that would be the way we implement it tomorrow or the next time, because what I really try to do is not like teach someone or myself algorithms here until it is absolutely necessary. Because here you see I write like, okay, cheap iterator, super primitive non-binary search when we have tokens and we want to highlight starting from some begin. We want to find the first token which is there, so we jump Actually, here I scan until I find this token, but we can actually do the binary search to find the first token, and then start rendering tokens, doing this. Yeah. Sometimes you really need it, and it really speeds up everything. But if we had like a text editor, maybe that would be a thing. Anyway, that's great. I think that's it. Let's wrap up, and thank you very much. See you next time.